In this lecture, we're going to take a more detailed view of hypothesis testing and the issues that can come up sometimes when errors are made on study conclusions. And our discussion of making these errors in hypothesis testing will factor into the fundamental application of various statistical outcomes. So when we talk about these errors, when we complete a research study and we analyze the statistics, we end up having to make a decision on accepting or rejecting the null hypothesis. And so once we complete our calculations, we then go back to the initial part of a research study. We look at the hypothesis null statement and we either accept that statement or we reject the statement. If we accept the null hypothesis, we take that statement to be true and thereby reject the alternative. On the other hand, if the statistics indicate that we reject the null hypothesis, we therefore will accept the alternative hypothesis. And this is based upon the results of statistical testing and calculations. And so this table provides an overall summary of the outcomes that occur with statistical testing with respect to the true state of the outcome of the study or the true state of the population. So along the top, we look at the truth, which is what we are after when we design a research study. And along the vertical axis here is the decision that's made in terms of accepting or rejecting the null hypothesis. And that's going to be an outcome of the statistics of the sample, whereas the truth plays into the true pattern of the population. And so if we start with the truth, and if in reality the null hypothesis is true, if the null hypothesis is true, then we are stating that there really is no difference between two groups in a population. If the null hypothesis is false, then we reject it and we therefore accept the alternative, and we would say that truthfully there is a difference between two groups of a population. Now, when we conduct the statistical tests on a sample of that population, if we find that we reject the null hypothesis, if we reject the null hypothesis when in fact it is false, then we are making a correct decision. That is something referred to as statistical power, the ability of the statistical test to detect a difference between two groups when it truly exists. On the other hand, if we accept the null hypothesis, so we do not reject the null hypothesis, by accepting the null hypothesis, we are making a statistical based decision that there is no difference between the two groups. And if in fact there is no difference between the two groups in a population, then that would be a correct statement. However, we know that in reality, there's always the risk of committing an error. The two types of error that we will discuss, the one that is used most commonly is what's called a type 1 error. A type 1 error occurs when we reject the null hypothesis when it is in fact true, when we should be accepting it. That is called the symbol alpha is used to signify a type 1 error. On the other hand, if we accept the null hypothesis, when in fact it should not be accepted, when it is actually false, then we will have committed what's called a type 2 error or a beta type of error. So we'll discuss some of the issues related to the errors here shortly with an example. So the type 1 error is also referred to as the alpha level that you will see very commonly in many research papers. And this establishes what's called a level of statistical significance. And it basically goes to a basic question that are the observed differences between groups due to random chance? So what is the probability that the differences that were observed in the study was no different than what would occur by chance? There's always that probability of happening. And we'll go back to our study comparing blood pressure between young and older adults. So using our example here, we start with the null hypothesis. So we've come back here and we start with a statement, a declarative statement, that the population average of blood pressure in young adults is going to be the same as that in older adults. We then follow that up with the alternative hypothesis. In this case, the alternative hypothesis is non-directional because we just simply state that they're not equal. We're not stating that young is greater. We're not stating that it's lower. We're just stating that they're different. So these are the two automatic types of statements that begins the process of hypothesis testing in every study. So now what is the next step? The next step is to collect our samples, to actually measure blood pressure in research participants with methods that are both reliable and valid. And then once we obtain the results from both groups of participants, we calculate descriptive statistics for each group. That is always the first step when sampling data. We calculate the mean and standard deviation. Because we're dealing with small sample sizes here, so 20 and 20, we perform statistical testing. And then we conduct what's called a t-test that will be detailed later. So the t-test refers to a set of calculations and statistical procedures that will come back and use the outcome to accept or reject the null hypothesis. So we conducted our study, we've conducted our statistical test, and now we have to come to a decision of accepting or rejecting the null hypothesis. So based upon the statistical outcome of this test that will be detailed later, it's a set of calculations, we then come back to the null hypothesis, and if the statistics suggest that they're not different, then we would accept the null hypothesis. Or we would reject the null hypothesis if the statistical outcome indicated that there is very likely a difference in blood pressure. So by rejecting the null hypothesis, we accept the alternative and we just read the statement here that they are different. So in our example, we're going to reject the null hypothesis. So once again here we have our declarative statements at the very beginning. We reject the null hypothesis. Therefore, we accept the alternative and we conclude that blood pressure is different between young and older adults. And this is a direct statement based upon the fact that our alternative hypothesis statement was non-directional. However, in reality, we don't truly know if they're different in the population. We could be making that mistake. So even though our statistics based upon our sample, 20 in one group, 20 in the other group, suggests to us that they're different, but we could be making that mistake of saying that there's a difference when there really is not a difference. And so how much risk are we willing to accept to make that mistake? Are we willing to accept a 10% error rate, 5%, or 1%? And that level of risk really depends upon the real life consequences at arriving at a wrong conclusion. The wrong conclusion is that we say that they're different when in reality, it's really not that different. And so to work through another example of illustrating the consequences of committing a type 1 error, remember, when you hear the term type 1 error, two words should come to mind. The word alpha, that the alpha level is another term for type 1 error, and the other term to associate that automatically is the word reject. And we always go to the null hypothesis. We don't go to the alternative, we go to the null hypothesis. And so when you think type 1 error, the word reject should come to mind. And because we start with the null, we reject it. And if you reject it, your only option is to go to the alternative hypothesis. Alternatively, if your statistics indicate you should accept the null hypothesis, then you don't need to worry about the alternative because that's a statement that they are the same. But to come back to the risk of making a wrong decision, we're going to look at an example here of a person that is on trial for capital murder. And in the United States and other countries, that is considered a death penalty case. However, not in Canada. Of course, Canada abolished the death penalty decades ago. So if we use this example of a person on trial, we state the null hypothesis. The null hypothesis from a statistical perspective, again, we go back to the word null. Null means zero. So we state that the statement is that the defendant is not guilty. That is a statement of the null hypothesis. Now, the alternative is just the opposite of that. We state that the defendant is guilty in this case. Now, we accept a type 1 error rate of 5%, and this will have an implication on the statistical testing that we alluded to in an earlier video with respect to the 90%, 95%, and 99% confidence levels. Okay, so now what we're going to do is we're going to commit a type 1 error. So if we go through our statistics and we commit a type 1 error, recall, type 1 error, always associate the word reject with it. So you remember the word reject, you come back up to the null hypothesis, which is a statement that the defendant is not guilty. The statistics indicates that we reject the statement. If you reject the statement, you go to the next statement below. This is the statement that therefore is accepted, that the defendant is guilty. However, if we commit an error in that conclusion, we are stating that the defendant is guilty because we rejected the null when it should be accepted, when the null should be accepted. So we're saying the defendant is guilty when in reality they are not guilty. And that has very significant complications here because if a defendant is found guilty, but in reality they are not guilty, the consequences is that the person will be subject to the death penalty. So the other type of error that can happen is what's called a type 2 error or a beta error. And we're going to go back to the blood pressure difference between young and older adults. So in young adults versus older adults, we have the same two sample sizes. We have the same null hypothesis, the same alternative hypothesis. And so in terms of committing a type 2 error, what is happening with this situation? Remember, the type 1 error, you associate the word reject. When you go to a type 2 error, the word accept should be applied, and that indicates that we go back to our statistical hypothesis, our null hypothesis, and we accept it. However, in this case, because we could be committing a type 2 error, we accept the null, we state that blood pressure is not different when it should be rejected, when in fact blood pressure is different between young and older adults. So in conclusion, we state that blood pressure is not different between young and older adults because we accepted the null, when in reality it is different. And so all of these statements all of these conclusions will have a certain degree of consequences. And so the consequence of committing a type 2 error in this example suggests that there should be no additional medical screening for older adults for the possibility that they could have higher blood pressure when the study suggests that it is not different between young and older adults would not be seeking those additional screenings or possible remedies for higher blood pressure. So this ends this lecture on the types of errors that occur with hypothesis